Hi, welcome back to my class series on engineering chemistry, Visheshwara Technological University, 21 CHE 12/22, module 4, green chemistry and alternative energy resources. This is a new topic which is added to the syllabus. It's part 1, green chemistry. I'm explaining here. Continuous classes will be available in my YouTube channel, my YouTube channel. So this particular class, I'm covering the topics like introduction to green chemistry, definition of green chemistry, and major environmental pollutants. Then basic principles of green chemistry. There are 12 principles of green chemistry, which is very important to understand, as well as we should follow those basic principles of green chemistry. So all the classes are available in my YouTube channel, my intuition. Please do subscribe my YouTube channel and share to maximum. Okay. So definition. Green chemistry, it is defined as the invention or design or development and applications of chemical products and processes to reduce or to eliminate the use and generation of substances hazardous to human health and environment. That means in order to avoid the release of hazardous chemicals to the environment, which causes pollution, not only to human being, affecting the health of a human being, polluting the environment as such. Therefore, we have to invent a new method, or we have to introduce a new design, or we have to develop a new method, and these should eliminate the use and generation of a hazardous pollutant to the environment. That is a definition of a green chemistry. Now, to say about green chemistry, it is also known as a sustainable chemistry because we need to sustain in this environment, in this world. We cannot live further in this polluted environment, so we have to be sustained. Next generation, at least, they should get a fresh air, fresh drinking water. So we should have this sustainability. Therefore, green chemistry is also called sustainable chemistry. To enhance the production efficiency, minimize the waste generated during the production. So green chemistry is also important because it enhances the efficiency of production. Waste generation will be minimum, and you must follow few of the green strategies like avoiding the wastage. We have to be atom economic. What is atom economic? I'll explain in my class video. Means whatever the chemical reaction that we plan, the atoms present in the reagent, the same number of atoms should be there in the product, main product, not the side product. Then we can say that it is atom economic. There is no wastage as such. To avoid auxiliary substances, that is adding additional solvents or other substances to support the reaction, which is becoming a waste only, which is not participate, which is not involving in the product formation. It becomes a waste, so polluting the environment. So to avoid auxiliary substances in the reaction, to use a recycled catalytic amount of catalyst. That means you have to use the catalyst that to recycled from once it is used, it is recycled, and the required amount of the catalyst only will be using. We will not allow the catalyst also to go in as a wastage. Reduced energy requirement and the energy efficient. That means whatever the process, chemical reaction process or any other related processes, if you have, we should have take a minimum energy required for that. It may be thermal energy, it may be electricity. So whatever may be the form of energy, the minimum energy has to be consumed, and it has to be energy efficient. Use renewable materials and biodegradable material. Whenever we want to do an synthesize or a chemical reaction or anything related to that, we have to find alternate one. If it is a non-renewable, so usually we go for petroleum products. So that is non-renewable source of material. We have to go for renewable source of materials, or which are can undergo biodegradation. Then it will not pollute the environment. Now, the major environmental pollutants, there are many, 10 to 15 environmental pollutants, out of which 3 major environmental pollutants I'm explaining here. So, given the table like pollutant and types, source of production, effects on human and environment. So, first one, that is oxides of carbon. Oxides of carbon, generally we write as COX. It can be carbon monoxide or carbon dioxide, CO2 as well as CO. Carbon dioxide is CO2, carbon monoxide is CO. Now, how these are produced? That we already know. It is produced by the combustion of coal or oil, and other fuels for energy production in the manufacturing as well as in transport. A lot of carbon dioxide and carbon monoxide are produced. It is also produced by burning the biomass. Now the effect, carbon dioxide has a major role in greenhouse effect. We know how it is greenhouse effect. It forms a layer on the atmosphere, which causes increasing the temperature of the, which will not allow the escape of the radiation which is reflecting from the Earth's surface, and further creating the increase in temperature, we call it as greenhouse effect. It produces weak carbonic acid adding to acid rain. Means this carbon dioxide, when it mixes with the water, it will convert into carbonic acid. Then along with the water, it comes as acid rain. Carbon monoxide affects human health by binding to hemoglobin. The second pollutant, that is oxides of sulfur or SOx. There are sulfur dioxide is there, sulfur trioxide is there, then sulfate is also there, sulfate ion. Okay, it may be sodium sulfate, potassium sulfate, ammonium sulfate, like that. Okay, therefore, three types are there: SO2, SO3, as well as SO4 minus. The source of production, that is again combustion of sulfur-containing fuels like coal. Petroleum extraction and refining process, it produces a lot of oxides of sulfur. Paper manufacturing industry produces. Municipal incineration process, release of sulfur, oxides of sulfur, and ore smelting for metal extraction also produces oxides of sulfur. Sulfur dioxide can cause damage to human and other animal limbs. It is an important precursor to acid rain. Adverse effects include corrosion of paint, metals, and injury or death to animals and plants. Okay, so sulfur dioxide, it can mix with the water, it will be converted into sulfuric acid. Then it becomes, along with the water, it becomes acid rain. That acid rain, because it is acidic nature, the corrosion rate will be passed to the paint or metals, and further it causes injury or death to animals and plants. A third one, that is oxides of nitrogen, NOx. There are nitrogen oxide, NO, nitrogen dioxide, NO2, and nitrous oxide, N2O, and then nitrate, NO3 minus. Okay, so four different types of oxides of nitrogen are there, and they are formed by burning of fuels, biomass burning, byproduct in the manufacturing of fertilizers, and they affect, it form a secondary pollutant, peroxyacetyl nitrate and nitric acid. Oxides of nitrogen can be converted into peroxyacetyl nitrate and nitric acid easily. Then we call it as it's a secondary pollutant. Then suppression of plant growth and tissue damage. It causes irritation to eyes, so viral infection like influenza. Nitrate form in atmosphere impairs the visibility also. So these are the effects of oxides of nitrogen. Now, what green chemistry and pollution, they are connected. Green chemistry, it reduces pollution at its source by minimizing or eliminating the hazards of chemical feedstock, reagents, solvents, and products. So if a technology, it reduces or eliminates the hazardous chemical used to clean up environmental contaminants, this technology would qualify as green chemistry technology. So any technology which a newer technology which reduces the production of hazardous chemicals or pollution, then that type of technology we can treat as green chemistry technology. One example is replacing the hazardous absorbent or sorbent, which is a chemical used to capture mercury from the air for safe disposal with an effective but non-hazardous solvent. So already mercury in the atmosphere, which has to be absorbed, which has to be removed. For that, a sorbent is used. The sorbent itself is hazardous. Now we have to find a replacement for that. Hazardous solvent should be replaced with a non-hazardous solvent to capture the mercury. So that is just an example how green chemistry can support or can help in avoiding the pollution. Now, very important topic, that is basic principles of green chemistry. Principles and explanation and illustration given two tables. The first principle of green chemistry, that is better to prevent than to cure. Okay, so from the principle itself, it is clear. Design chemical synthesis to prevent waste. Leave no waste to treat or clean up. That means this technology is aimed to develop a zero waste technology, ZWT. In terms of this zero waste technology in a chemical synthesis, waste product should be zero or minimum. It also aims to use the waste product of one system as the starting material or raw material for other synthesis or other systems. That means whatever waste if formed, it has to be used for some other application. Then zero waste will be there. Now, example, if you take the bottom ash, the ash formed in the thermal power station after burning the coal or biomass, it can be used as a raw material for the cement and the brick industry. I already explained in my class of cement that ash cement, they use the ash of the thermal power plant to make the cement. It mixed with the cement and used. The effluent coming out from cleaning of machinery parts may be used as a coolant water in thermal power station. So to wash the machine parts, a lot of water is used. That water which is coming out from that, it can be used than making it to flow directly to the water body. It can be used as a coolant in thermal power stations. A lot of coolant is required in thermal power station. The municipal waste, whatever the waste coming from the municipal, it can be used as a source of energy. So these are the supporting thing which to the principle one of green chemistry. Now the second principle, that is atom economy. Atom economy in detail I'll be taking a class, continuation of this video class, and the next two next video class will be on atom economy. The design synthesize so that the final product contains the maximum proportion of the starting material. Okay, so if the starting material required, then the amount of atom, the proportion of atoms present in the starting material and the at the end product, the same proportion if it is there, that means 100% atom economy. That means there is no wastage. Waste few or no atoms, that is the concept behind the atom economy. Now the third principle, that is less hazardous chemical synthesis. Design synthesis method to use and generate substances with little or no toxicity to either humans or to the environment. That means this principle aim to develop the methodologies that will minimize the use and formation of toxic and hazardous substances. The fourth principle says that designing safer chemicals. Design chemical products that are fully effective and have little or no toxicity. In many chemical industries, the raw material, starting material itself is hazardous to the workers and the environment. One such example is benzene, which is used in acetic acid. Okay, for example, benzene is the starting material for the synthesis of acetic acid. Benzene is carcinogenic and it is a volatile organic compound which pollutes the air. Therefore, the industry which uses the prepare the adipic acid, they are using benzene as a starting material, and the people who are working in the industry, they are getting affected with that. Therefore, green chemistry concept or green chemistry approach now uses glucose as the starting material. So glucose, we know it is not a polluting or it is not carcinogenic. It is actually a requirement for us as the starting material. Glucose is used as a starting material for the enzyme catalyzed adipic acid synthesis. So synthesis of adipic acid I am explaining in my class video. The next class video, it is the synthesis of adipic acid using the starting material as benzene as well as using glucose. The comparison and the mechanism of reaction also I am explaining that. Now the safer solvent and reaction condition, the fifth principle. Okay, there are 12 principles. We reached on to fifth, safer solvent and reaction conditions. That means avoid using solvents, the separation agents or other supporting chemicals. If you must use these chemicals, use safer ones. This wherever required, avoid the solvent. Better to go for solvent-free reactions. Okay, solvent one, what we use a solvent so that the reaction will be speed up in a liquid media, or let's say liquid media. The solvent which is not involved in any reaction, it become waste, or anything which is used as a separating agent to separate the major product from the minor product. Those we wherever possible we have to avoid, because that is where further we cannot reuse it, or easily it is thrown to the environment. Okay, so wherever possible, avoid it, or if you are using, we have to handle it properly so that it will should not pollute the environment. This principle also aims to use green solvents such as water, supercritical carbon dioxide, in place of volatile halogenated compounds, and if possible, solvent-free synthesis is preferred. That means wherever possible, use water as a solvent, because than other solvents which are costly and which are produced from non-renewable sources like petroleum products. Better go for water. Water we can purify and reuse it. For new concept known as supercritical conditions, supercritical carbon dioxide, carbon dioxide CO2, the two should be subscript. It should be subscript CO2. Okay, I'm not changing it right now. Okay, so you have to write a CO2 carbon dioxide. This is carbon dioxide. Okay, so you have to use such newer condition, critical conditions, which in which the additional solvents are not used, and we are reducing the wastage. The sixth one, that is designed for energy efficiency. Increase energy efficiency, that is by running a chemical reaction at room temperature and pressure whenever possible, than going for a high temperature, a high pressure, which is more energy consumption is there. It needs suitable catalyst that will accelerate the reaction rate even at lower temperature. That means if catalyst is used, then we can reduce the reaction temperature, and that is the less usage of energy. The biocatalyst, like enzymes, it can work at ambient conditions. Therefore, even if you use catalyst, also better go for biocatalyst or enzymes. Energy save can be done in many other ways, like refluxing conditions, than just heating. Refluxing means it is in a closed container. Whatever the vapors, it will be condensed back to the solution, the reaction medium. Therefore, there is less wastage and more efficiency is there. More conversion is the reaction conversion is there if it is a refluxing condition. Waste heat may be used for heating other chemical reactions. Whatever the heat produced in one reaction, that heat can be used for heating the other chemical reaction. Improving the technology for heating systems, that means using a microwave heating, which preferences for photochemical reactions, microwave heating or photochemical reactions using solar energy instead of the thermochemical reactions. Extraction of energy from waste product means wherever waste product is there, we have to generate energy from that, and that can be used. That is the principle number 6, design for energy efficiency. Seventh one, that is renewable feedstocks. Use starting materials known as the feedstock that are renewable rather than depletable. Most of the feedstock that we use are petroleum products for many different product synthesis or chemical reactions. Better to replace it with a non-renewable from non-renewable sources, or which are not depletable. The sources of renewable feedstock is often agricultural product or the waste of other processes. The source of depletable feedstock is often fossil fuels like petroleum, natural gas, or coal or mining operations. The practice of this principle has been illustrated in many cases, like use of bioplastic and biopolymers, use of biodiesel, then carbon dioxide feedstock for the manufacture of polycarbonates. Carbon dioxide actually is a polluting gas. It can be used as a feedstock to get converted into polycarbonates, which is a useful polymer. Eighth one, that is the derivative reduction. That means wherever possible, you have to avoid the formation of derivatives or modifications or blocking or protecting agents, because some chemical reactions we plan such a way that one of the functional group should not undergo reaction, the other functional group has to undergo reaction. Therefore, the first functional group we have to convert, we have to block it. Therefore, it is converted into some other functional group by using a blocking agent or protecting group, which is a temporary modification, and we need to regain back the functional group. So these steps are additional steps which uses an extra chemicals or wastage of chemicals. Derivatives use additional reagents and generate waste during the synthesis of a chemical product. So this principle aims to develop the methodology where necessary steps should be avoided if practicable. Biocatalytic reactions are very often needed no protection of self-selective group. That means if it is a biocatalyzed reaction, then such type of protection is not required. Therefore, wherever possible, we have to use the biocatalyst to catalyze the reaction than doing the temporary modification like using a blocking agent or protecting groups, etc. The ninth one uses catalysis. Use catalysts wherever possible. Minimize the waste using catalytic reaction. We know the catalytic reaction. It speed up the chemical reaction without involving, and it will be a more efficient reaction. Catalysts are effective in small amount and can carry out a single reaction many times. They are preferable to stoichiometric reagents, which are used in excess and carry out the reaction only once. Stoichiometric reagents are some of the chemicals like some solvents which are used in excess not to make the reaction to happen, but they are not at all involved in the product formation. It becomes a waste. Therefore, catalyst can be used. Degeneration, that is a 10th principle. Degeneration, that means you have to design a chemical product to break down to degradable substances after use, so that they do not accumulate in the environment. That is, it should be undergoing degradation. Otherwise, it will be pollutant. It should be the final product or any byproducts are formed. It should undergo degradation. That is the concept of the 10th principle. Thus, the use of biodegradable plastic product and biodegradable pesticides are always preferred than non-biodegradable ones. Even the degraded product should not be toxic. Therefore, you have to plan everything such a way that it should undergo degradation, and the degraded product also should not be toxic in nature. The 11th principle says real-time analysis for pollution prevention. That means whenever a chemical reaction happens in industry, every second it has to be monitored, and wherever there is a formation of a toxic gas or anything hazardous chemicals are formed, we have to control it or we have to stop the reaction. We have many different analytical method, advanced analytical methods, and even we can develop a new methods which can prevent the real-time inline process monitoring, which can assist in real-time inline process monitoring and control well before the hazardous substances are generated. 12th one, accident prevention by inherent safer chemistry. Accident prevention by inherently safer chemistry. The compounds, the physical form like solid, liquid, or gas, and the compounds formula applied in a chemical process should be chosen in a way minimizing the risk of chemical accident, encompassing the release of chemicals, detonation, or fire formation. That means we know there are three different phases like a solid phase, a liquid phase, a gaseous phase. All these phases can react. If it is a gaseous phase, then there is always a pressure development, change in pressure, which is always difficult one to control, because the plants which we use close the containers, we have to do the gas reaction. It may burst, it may explode. If it is a liquid also, there is a chances of converting into gases easily, and explosion can happen. So wherever possible, we have to go for these solid forms. The starting material should be solid form. The reagents, reactants should be in solid state. Then we can avoid this risk of accident, that explosion or detonation or release of polluting gases to the atmosphere. It can be controlled. That is the meaning of the 12th principle. That means if the chemical process works with the gaseous substances, then the possibility of accidents, including explosion, is relatively higher compared to the system working with the non-volatile liquid and solid substances. That is about the 12th principle. So my this particular class ends here. It is available in my YouTube channel, My Intuition. Please do subscribe the YouTube channel and support me. I thank you very much for watching this video, and have a nice day.